Hi everyone, welcome to Algebra 1, Solving Complex Inequalities, where this video is going to go over practice problems that are difficult. And usually difficult in math, particularly Algebra 1 means that it's a longer problem, or it involves fractions, or it involves some trick that I want to highlight in the video so that you are familiar with and you don't get overwhelmed when you come across it. So for number 1, we have a problem that is particularly very long. This means we have to simplify it and nothing more. It just takes us combining like terms and simplifying as much as we can. So on the left, I have a negative 7x and a positive 5x. That means I can combine that, and I'm going to have a negative 2x minus 10. And then I'm going to distribute on the right, so then I have 3x plus 12 plus 8. I can further combine that 12 and that 8 to be 20. Now I am going to work towards isolating the variable on one side and for it to be by itself. So if it's negative, it's going to be positive 2. So positive 2 plus 2x, negative 10 greater than equal to 5x plus 20. Then I'm going to subtract 20 to get rid of it on this side. That's going to be negative 30. Greater than equal to 5 over x. I'm going to divide by 5. The answer is going to be negative 6 over x. Let's make that prettier, better looking. Negative 6. Okay? Now, the second one is only more difficult because it involves fractions, and fractions are just a pain. They're not bad, they're not good. They just require more work. So I'm going to do some fraction work here on the side. Try to put it like here. So we have 1/5, 1/2, 4/5. We need to find a common denominator, because once you find the common denominator, it makes the process a lot more easier. The next up denominator that is possible to satisfy all three would be 10. So that's the one I'm going to use. And what did I do to get this to 10? If I had to multiply it by 2. So I have to multiply it by 2 at the top. And that's going to be 2. For the second one, I had to multiply it by 5. So I have to multiply at the top by 5 as well. That gives me 5 over 10. That doesn't look like 5 though. 5. And then for the bottom one, times 2 times 2, that's going to be 8. Now, what I'm going to do is rewrite this equation with fractions that are equivalent to the originals, but they look better for simplification purposes. So it is now 2 over 10x plus 5 over 10 is greater than 8 over 10. Now, I can multiply both sides by 10 to get everything simplified. Now it becomes 2x plus 5 greater than 8. Isolate the variable by moving things away from it. 3 divided by 2 divided by 2, x is greater than 3 over 2. And you can also do or 1/2. Either way is the right answer. They're just different ways of saying the same thing. Okay, for this problem, we have d minus 2 is greater than d minus 4. Now, trick, and I want you guys to train your eyes. Look at the variable. It's d and d. Remember, in the lecture video, when I was going over the concept, whenever you have the variable on both sides being the same, you can kind of skip doing a lot of the work, as opposed to these two where they weren't the same. Like we had 2x, negative 2x, and a 3x. Those aren't equal. And then here we only had the variable on really one side, so it doesn't apply. But here we have just d and d. So we can treat them as if they're not really there. So I'm just going to like do a squiggly line between them. And then you bring everything else that was involved down and you compare them. So -2 is less than -4. Now we need to ask ourselves, is that possible? So is -4 always greater than -2? It's never greater than -2. So that's a false statement. Therefore, this is a no solution answer because that will never be true. Okay, going to the last one. Looks like we have to do some simplification. So it's going to be 2 minus 2x greater than -2 minus 2x. This is a situation again where I have the same variable on both sides. I have a -2x and a -2x. So I can somewhat just cross it out a little bit, act like it's not there, and then I do bring down everything that was involved. And 2 is always greater than -2. So then that's true. Therefore, this little symbolization means therefore it's all real numbers. Hope this was helpful to y'all. I'll see y'all next video.